Hi, this is Mrs. LaBarbara. This is Physics Chapter 3 Vectors Video 2. Today's topic is Adding Vectors Graphically Part 1. The objectives are: know the difference between vector sum and algebraic sum. Understand two ways to determine the vector sum graphically. Be able to add vectors graphically. Determine the magnitude of a resultant vector using a scale and the direction of a vector using a protractor. Adding vectors. A boy walks 3 meters north and 4 meters east. To determine the distance traveled by the boy, we add two values together and we get 7 meters. This is because the distance is a scalar quantity. The sum of scalar quantities is the algebraic sum. So here's vector A represents 3 meters north, vector B represents 4 meters east. The distance is 7 meters. However, to determine the displacement of the boy, we draw an arrow starting from the tail of A, that's the beginning, to the head of B, that's where you end, and we'll get this vector R. This vector R is the vector sum of A and B, and we call this R as a resultant. As you can see, the resultant vector A plus vector B is different from the value of A plus value of B. Value of A, that's a magnitude of vector A plus a magnitude of vector of B. Use head-to-tail vector diagram to determine a resultant. Suppose that you are given a map of your local area and a set of 7 directions to follow, starting at home base O, right over here. These 7 displacement vectors could be added together in consecutive fashion to determine the resultant. So you start from 80 going to the east, then 120 to the north, east, north, then west, south, and finally going to west again. You can determine the resultant vector. So the first vector, suppose the first vector is measured 8 centimeters. You use the scale of 1 centimeter equals to 10 meters east. Where this measurement ends, right over here, the next measurement would begin. So you will have 12 centimeters going up north. Then where the second one ends, you will start with the third vector, and so on. In essence, you would use the head-to-tail method for vector addition. So the resultant, you would from your home base to where you ended, your destination. That is your resultant. So resultant is not tip to tail, but from where you start to where you end. How to determine the sum of 2 or more vectors using head to tail? So first you have to choose a scale and indicate on a sheet of paper. So the best choice of a scale is one that will result in a diagram that is as large as possible, yet it fits on a sheet of paper. Next, you pick a starting location and draw the first vector to scale in the indicated direction. So make sure when you have your starting location, make sure everything fits on your paper. You need to label the magnitude and direction of the scale on the diagram. For example, you can say 1 centimeter equals to 20 meters or 1 centimeter equals to 5 meters, so forth. Starting from where the head of the first vector ends, right? Draw the tail of the second vector to the scale, again in the indicated direction. Label the magnitude and direction of this vector on the diagram. And repeat until you finish every vectors. Finally, again, I can't emphasize enough to draw the resultant from the tail, that's the beginning of the first vector, to the head, that's the end of the last vector, and label this vector R. Using a ruler to measure the length of the resultant to determine the magnitude by converting to the real units using the scale. Finally, you have to measure the direction using a protractor. Always measure the direction of the tail of the resultant. From there, you determine the direction. So here is an example. So you start from A. So here is the magnitude of A, the length of A is the magnitude. Here's the direction. So measure from the east, counterclockwise, measure that direction. Then you continue from the end of A to measure B. So again, you put a coordinate at the end of A to measure the direction from the end of A. Right over here, you have B, then you continue for C and keep going. Your resultant is from A to the beginning of A to the end of C. So that is your resultant. To measure the direction of resultant, you use the tail, the direction of the tail of resultant, and measure from the east. Let's take a look. These are special cases to determine resultant. The first one, the two vectors happen to be 90 degrees. The second one, the two vectors are in the same direction, so the angle between the two vectors is 0 degrees. The third vector, they are in the opposite direction, so the angle between the two vectors are 180 degrees. For the first one, the resultant is from beginning to the end, so that's a tip to tail. For the second vector is the same way from the beginning to end. For the third vector, again, it's from the beginning to the end, but the second vector has to start from the tip of the first vector. So the resultant is the beginning to end. So as you can see, when the two vectors are in the same direction, you have a maximum resultant. That's the biggest value you can get for resultant. And this one, they are 180 degrees, you have a minimum resultant. And everything else is in between the maximum and the minimum. So the sum of any two vectors A and B can have a maximum value of A plus B and a minimum value of A minus B. An example, a dog walks 8 meters due north and 6 meters due east, like showing you in the diagram. Now you have to use a metric ruler and a vector diagram to determine the scale used in the diagram. So if I use a ruler here, which I did, I get 1 centimeters equals to 4 meters. So according to my ruler, this is 2 centimeters. So 2 centimeters is 8 meters. That means 1 centimeter equals to 4 meters. Now on the diagram, construct the resultant vector that represents dog's total displacement. That's from where you start to where you end. That is your resultant. Next one, you have to determine the magnitude of total displacement. Now you have to use a ruler to measure the length of this R, which I measured. I have 2.5 centimeters. Then use the scale. 1 centimeter is equals to 4 meters. In this case, centimeter and centimeter cancels, so you'll end it up with 10 meters. Another example, a girl rides her bicycle 1.4 kilometers west. So west is going into this direction. And 0.7 kilometers south going downward, then 0.3 kilometers east going to the right in 12 minutes. Draw a vector diagram to represent a girl's displacement in sequence. Use the scale of 1 centimeters equals 0.2 kilometers. Determine the resultant of girl's displacement. So let's see, 1.4 kilometers west. If I use that scale, I have to draw 7 centimeters. So that 7 centimeters equals 1.4 kilometers west. Next one, I have to draw 0.7 kilometers south. So 0.7 kilometers, I have to use 3.5 centimeters. That gives me 0.7 kilometers. Then I have to draw another one, which is 1.5 centimeters. That will give me 0.3 kilometers going to the east. So for the resultant, you draw from the beginning to the end. Then you're going to measure this. I measured about 6.5 centimeters, so my resultant is 1.3 kilometers. To determine the direction, I have to use a protractor to measure that angle, which is 32 degrees. According to the directions we learned in the last video, this one is you're going to south from the west. So it's 30 degrees south of west. Adding vectors tail to tail or parallelogram method. So sometimes the vectors given to you are connected to tail instead of tip to tail. To add these tail-to-tail vectors, we can draw a parallelogram with the given two vectors as two sides of your parallelogram. So the resultant will be the diagonal of your parallelogram from the tail, starting from the tail of both two vectors. So you draw a parallelogram first, and the resultant is from the tail going to the other end. This called tail-to-tail, sometimes called concurrent vectors. So a lot of mistakes are made by people going directly from tail to tail. Never draw that. That is a mistake. That's not the resultant. Let's do an example. The vector diagram is given to you of two forces, F1 and F2. We learned in the last chapter, force is a vector. So here is vector force 1, vector force 2. Simultaneously acting on object. Which vector represents the resultant? So this is tail to tail. We need to draw a parallelogram. The resultant is your diagonal. So as you can see, A is your resultant. Another example. So this is again vector given to you tail to tail. So a model airplane has due east at 1.5 meters per second, while the wind blows due north at 0.7 meters per second. The scaled diagram below represents these vector quantities. Use a ruler to determine the scale used in the vector diagram. So again, use a ruler. I use a ruler. I measure the whole length is 3 centimeters. So I get 1 centimeter equals 0.5 meters per second. Next one, on the diagram, use a protractor and a ruler to construct a vector to represent a resultant. So because this is tail to tail, I have to draw a parallel diagram. So diagonal is the resultant. I label it R. Next one, to determine the magnitude of resultant vector. To determine, I have to use a ruler to measure how big it is. So I measured 3.3 centimeters. Now I use the scale of 1 centimeter equals to 0.5 meters per second. I get 1.65 meters per second. Next one, I determine the angle between the north and the resultant. This way is north. So I have to determine this angle and measure that to be 65 degrees. That's it. Thanks for watching. See you next time.